Hello guys, so under vector analysis 2, I would like us to look at line integrals. Now, line integrals are basically evaluated from the formula integral of curve C, integral of V with respect to dr, where V is our given scalar field and dr is basically I dx plus j dy plus k dz. Now, in practice, you'll find that the values of x, y, and z are often expressed as parametric equations. So you'll find that they are written in terms of like a totally new variable. So we will obviously express V in terms of this variable and also dr in terms of this variable so that we can be able to evaluate. Now, let's take up a question here. We are being told that V is equal to x y squared z. So find the line integral. So how do we get the line integral? So the line integral is defined by this formula here, and I'm going to express it down here, this formula here, so that you can be able to follow and see how exactly we go about it. So in our solution, what we want to evaluate is integral of V dr. Now, what is our V? Let's start there. Our V is given by xy squared z. Now, clearly, as we can see, we have our x, y, and z being expressed with respect to another variable. So I'm also going to write V in terms of that variable. So what is x? My x is 3u. What is y? Y is 2u squared, but y has been squared and then multiplied by z, which is u cubed. So what's my new value of v with respect to variable u? So this will give me u raised to power 1, u raised to power 4, that's u raised to power 5, then u raised to power 3, that's u raised to power 8. 3 multiplied with 4, that will be 12. So the value of my V is 12u squared. Okay, fine. Next, let's get the values of dr. Now, as we've said, dr is equal to, so let me write it again, dr is equal to I dx plus j dy plus k dz. Now, we already know the value for like x is equal to 3u. Now, if x is equal to 3u, what is dx du? Dx du will obviously be given by 3. So basically means that dx is equal to 3 du. Okay, moving on, y is equal to 2u squared. So what is dy du? Dy du is equal to 4u. So meaning our dy is the same as 4u du. Then finally, our z is equal to u cubed, meaning our dz du is equal to 3u, sorry, our dy, okay, this is okay. So 3u, 3u squared. So what is our dz? Our dz is the same as 3u squared du. Now, having all that, the next thing is we are being told that these values are defined from A to B. So these are obviously given in terms of x, y, z, x, y, z. So we need to find these expressions. What will they represent in terms of u? Now, let's come and work with the limits. So we have A is equal to 0, 0, 0. So we need to get the value of u. And B, let's just finish with A. So X is equal to what? 3U. So Y is equal to what? So let's just go with X first. X is equal to 3U. And you can see here the value of X, Y, Z. Our X is 0. So when X is 0, what's the value of U? Put 0 here. We will have 3U. So U will be equal to what? 0. Let's take up the value of Y. Y is equal to 2u squared. When y is 0, what will be u? U will also be equal to 0. And z is 0. So let's first of all write the expression for z. So z is equal to z is equal to u cubed. Now, when our z is 0, what will be the value of u? So clearly, u is equal to 0. That is for this particular point. What of for point B? Point B is given by 3, 2, 1. So for point B, we have 3, 2, 1. 3, 2, 1. This basically being the value of x, y, z. Okay, x is equal to 3u. So what's the value when x is 3? When x is 3, we will have 3u. So our u will be equal to 1. Okay. Now, when y is equal to 2u squared, y in this case is 2. So when we have 2 there, then this is going to give us 2u squared. So this will give us u is equal to plus or minus 1. Okay, and finally, our z, which is equal to u cubed, our z here is 1. So replacing the value with 1, we have u cubed. So what's the value of our u? 1. So this particular point here just translates to u is equal to 1 as our limit. So coming to evaluate the integral, we are evaluating integral of the curve. So let me write again. Line integral is given by integral of curve v dr. And we've established that we're integrating from 0 to 1. What's our v with respect to the new variables? We found that our v is 12u raised to power 8. So our v is 12u raised to power 8 multiplied by dr. What is our dr? Now let's come here and write our dr in terms of u again. Dr is I dx plus j dy. So I want to express that our dr is I dx. But what is dx in terms of this new variable? We've already established that dx is the same as 3 du. So I will have this as 3 du plus j. What is dy? Our dy with respect to this new variable is 4u du plus finally k dz. And our dz with respect to the new variable is 3u squared du. And we are supposed to integrate this with respect to the new variable, so with respect to u. Okay, fine. So how do we go about that? So let's simplify this, then integrate. So this is going to give us, I can take the 12 outside. Then I have the integral from 0 to 1 of 3u I du. So 3u I du plus, let me write the I in front so that you can be able to see what exactly we're integrating clearly. So let's have I, then we have 3u raised to power 8 du. Multiply this by this, the 12 I've taken it outside the integral sign, plus j, 4u is now raised to power 9 because we multiplied it with this u raised to power 8 du, plus finally k, we have 3 here. So, okay, then we have 3, u is now raised to power 10. And then we have u is raised to power 10. And then we have our du there. U is raised to power 10. And then we have du. Okay, so, we have du. Now integrating this du here is not supposed to be there because all these values come with their the du's. Okay, fine. So integrating each term, then what are we going to have? So integrating each term, we'll have 12 out there. Integrating this first term, this will be 3 over 9. So let's write the I there. 3 over 9 u raised to power 9 plus j 4 over 10 u raised to power 10 plus k 3 over 11 u raised to power 11. So what does this simplify to? This is going to be our line integral. So this is the answer. This is equal to multiply by 12. So this will give 3 goes here, and 3 goes here. We'll have 4, 3, 3. So we'll have 4 u raised to power 9 of I plus multiply by 12 here and simplify. This will be 24 over 5. 24 over 5. Oh, wait a minute. So we did not replace the ranges, guys. After integrating, we had the range here, range from 0 to 1. So replacing the range there after integration, we'll have 12 into replacing 1, 1, 1, 1, 1, 1. So this will just be 3 over 9i plus 4 over 10j plus 3 over 11k. Replacing 0, this will be 0, 0, 0, 0. So that will just be minus 0. So there's no need of writing that. Okay, so simplifying this now, this will give us 4i plus 24 over 5j plus 36 over 11k. And this is the answer for our line integral. Okay, fine. Let's take up another example, example number 2. So example number 2, we have our v is equal to xy plus y squared z. And then we are being told to evaluate the line integral of v along the curve defined by x is equal to t squared, y is equal to 2t, z is equal to t plus 5 between the points. So between the points, point A is 0, 0, 0, and point B, which is 4, 4, 7. Okay, let's go. So the idea is basically we are going to rewrite all this with respect to the new variable, and our new variable here is our t. So solution. Let's start by getting the value of v. So v is equal to xy plus y squared z. So what's the value of v with respect to the new variable? V is x is t squared. So t squared multiplied by y, which is 2t, multiply plus y squared, y is 2t, so 2t squared multiplied by z, which is t plus 5. So what does that simplify to? So our v will be equal to 2t cubed plus on this other side, so opening this bracket, this is 4t squared, so that will be 4t cubed, and then 4t squared plus multiplied with 5, so that will be plus 20t squared. So that will be it. So putting the like terms together, this is 6t cubed plus 20t squared. So we already have our value for v with respect to the new variable. Now, what is our dr? And then we go ahead and evaluate the limits as well. Now we know that dr is equal to I dx plus j dy plus k dz. Now, since we already have the values for x, y, and z, let's come and evaluate what they will be with respect to this new variable. Now, since x is equal to t squared, dx dt will be equal to 2t. So from here, we can be able to clearly see that our dx will be equal to 2t dt. So dx is equal to 2t dt. Now, y, on the other hand, is equal to 2t. So differentiating, dy dt will be equal to 2. So clearly, our dy will be equal to 2 dt. And finally, z is t plus 5. So since z is equal to t plus 5. Our dz dt will be equal to 1. So clearly dz is equal to dt. So we can clearly rewrite all these values for dr with respect to this new variable, so that our now dr with respect to the new variable, our dr will be equal to I. What is dx? Dx is 2t dt plus j, dy is 2 dt plus k, dz is dt. Okay, fine. So the next is to evaluate for the limits. So we've been given point A is 0, 0, 0 and B is 4, 4, 7. So let's start with point A. So evaluating for the limits of the curve, limits of integration. So we have point 0, 0, 0. So this represents X, this represents Y, and this represents Z. And we are being told that X is what? X is equal to 2t. So let me just write them here. X is equal to t squared, not 2t. Y is equal to 2t. Y is equal to 2t, and Z is equal to t plus 5. Z is equal to t plus 5. So what will be the values of t? Now, when x is equal to 0, if we replace here, when x is 0, t will obviously be 0 as well. When y is 0, if you replace 0 here, t will obviously be 0 if you solve. When z is 0, if you replace z with the value of 0, so let's see, the value of A is actually 0, 0, 5, not 0, 0, 0. So I wrote that. We need to change that. The value of A is 0, 0, 5, not 0, 0. So 0, 0, 5. That's how the question is. So 0, 0, 5. 0, 0, 5. So if you replace the value of Z with 5, you will obviously, if you replace the value of Z with 5, you will obviously get your T to be equal to 0. So obviously all this just translates to T is equal to 0. For the next point, B is 4, 4, 7. So let's do the same. Now we know that x is equal to t squared. So this is the value of x, y, and z. So for x is equal to 4, what will we have? So 4 t squared, so t will be equal to 2. Let's go. Y is 4. Y is equal to 2t. So if y is 4, 2t, t will be equal to what? 2. Finally, z is equal to t plus 5. So if z is 7, what will be t? T will be equal to 2. So this just basically translates to t is equal to 2 as our limit. So let's now write our line integral. So our line integral is given by v dr. So we've written all this with respect to new variables. We're integrating from 0 to 2. What's the value of our v? Our v with respect to the new variable, we got it to be 6t cubed plus 20. So here it is 6t cubed plus 20t squared. 6t cubed plus 20t squared. And then finally, the value for dr. So for dr, we have, here it is, so I2t dt, I2t dt plus J2 dt, J2 dt, and finally plus the value for k dt, k dt, k dt. So let's evaluate this. So let's see, we can be able to multiply this and then integrate. So we are having integral from 0 to 2 of the first term there is going to give us, if we multiply by 2t all through, we will have 12 t raised to power 4 plus 40 t raised to power 3, and then all this I dt plus next term, we have 2 multiplying the whole bracket. So that will give us 12t cubed plus 40t squared j dt plus the final one, we have 6t cubed plus 20t squared k dt. So this is basically what we evaluate to get our answer. This is basically what we evaluate to get our answer. Okay, fine. So let's see what this simplifies to when we come to integrate. Okay, fine. So this is going to be, so integrating this, we are going to have, so 12, that will give us 12 over 5, t raised to power 5, plus 40, 40 over 4, t raised to power 4, and all these are values of I, plus, integrating the next one, 12 over 4, t raised to power 4, plus 40 over 3, t raised to power 3. All these are values of j, plus 6 over 4, t raised to power 4, plus 20 over 3, t raised to power 3. All these are values of k, and we are integrating from 0 to 2. Okay, fine. Integrating from 0 to 2. So replacing our values of 2, what will we have? So replacing our values of 2 here. So 2 raised to power 5. Okay, we can do that. So if you evaluate this correctly, you should be able to get your answer as 8 over 15, 444i plus 290j plus 145k as the answer to your line integral.